I just wanted to kind of begin to share at least some of the, not references, but just some things that I was poking around and trying to get an idea of how to approach the problem, which is kind of what at least I like to do at the beginning of such competitions rather than diving into solutions. So kind of get into more of the what is termed EDA or exploratory data analysis, or even just becoming familiar with what the problem is. So with that in mind, let me just share few of the things that I started to poke around with so you can have an idea. I tend to go broad-based at the beginning of the competition before diving into the details. So with that said, let me see whether I can share my screen. Let me know if you can see it.
Yep.
Yeah, I can see it. Yep.
Okay, so, you know, as I said, this is a switch, you know, the basic description of the competition. As you can see here, there are a couple of, there are many tabs. The data kind of gives you the data, what are the various fields, what's the size and stuff. These are things that you can download to Google Drive, for example, and work there. The reason to do that is the number of hours that you get on Kaggle per week is limited to about 37 hours, I think, of compute. So all the hours you may spend interactively working on developing your notebooks count against that. It's not a big deal. I think if you're just doing a single competition, if you're doing multiple competitions and making multiple submissions, then that could become a problem. One of the things before going into the notebooks and the discussion and stuff is also what's the evaluation metric for the competition. That's something I typically like to know. And in this case, it's the log loss, fairly simple. But, you know, if you click on the link, at least for me, it gives a 404 error. It's a fairly simple metric. But again, in order to understand what the metric is, here is a link within the Kaggle channels itself that tells you or explains log loss fairly well. As I said, I'll post the links that I'm referring to here once we are done. But I think many of you are probably familiar with log loss already, but it just kind of explains the concept of how you get to the log loss and the fact that, you know, ultimately you're trying to get to estimating the likelihood function, and from that calculating the log loss, which is just a -1 times the log of the likelihood function. And the reason for the negative is so that we are consistent with the notion that the loss is expected in any kind of machine learning to be minimized, which means the lower the value, that's what you're seeking. So that's kind of the reason why there's -1 times the log of the likelihood function. So that's just a simple, you know, like to know what the metric is that we are optimizing for. The subsequent thing that typically I also like to do is to find out, you know, what are some of the techniques or what is the objective of the problem at hand that we are trying to solve. In this case, it seems as the description of the problem states, we are trying to simply determine whether two questions are the same. It's not as simple as the statement I just made, because ultimately we are after the meaning of the words in the question. But there are obviously several ways by which people tend to find whether two sentences, two paragraphs, two documents, in this case, a lot simpler, two sentences or two questions are the same. And it seems like the task at hand in NLP, obviously NLP as a whole is very vast, but in this case, it seems to be that what we are after is paraphrasing. And one of the ways, I think, if you're somewhat familiar with NLP, that you try to find, quote, similarity between two things is through various metrics of distance. So I kind of began to look at, what are various things that are talked about for similarity. But before that, you can again, in the discussion section, you'll see typically multiple things, including, because we take part in completed competitions, the description of first place, third place, blah, blah, blah. Initially, I would suggest that since we want to try solutions ourselves, is Gautam submitted, I think Yuri tried something last week. So I think I would encourage people to try and submit different ideas that each of us has by ourselves before we begin to look at, the first, third, second, 14th, whatever solution and what they are doing, in order to kind of face the challenge ourselves, use some ideas. But it's interesting to look at things like a beginner's guide or some interesting solutions in the web. Now, keep in mind that these are also dated, which is the good thing from Gautam's suggestion of trying a 4-year-old competition, is that these things refer to what was then current, and we can try different new things. But this beginner's guide is a good one to stimulate some thoughts of what you would want to try. As I was just saying, there are different metrics for similarity of the words. So what you're trying to find out is, hey, the words in the question, if they are similar, then are the questions similar? So maybe if we find the cosine distance score or the Jaccard score or the shingling, maybe that will tell us that the two questions are similar. There's a variety of different techniques that are described here. As I mentioned, some of them are dated, and you could probably improve and come up with new ways, but this is a good set of ideas to start with. Similarly, I think the next one were some interesting solutions from the web. Again, you can kind of chase down the various bookmarks pointed to. In fact, one of them, this guy here, is an interesting idea posted by the Quora folks themselves of the different types of approaches that at that point in time, which is, I believe, 2016 or 2017, that this is in 2017 that they were attempting. Again, there might be better approaches today, but these were the approaches they tried. And the interesting part of this is none of this is ready-made, in the sense that you can't just run an existing notebook. So that's both, they have enough idea here or enough pictures and ideas to generate this kind of a network, but then you have to code the network, and so that helps give us some practice of what to do. But these two notebooks that I pointed to kind of give you some ideas, starting points. The first one, for example, begins to talk about the cosine, the Jaccard, and the shingling. Given that there are some references I found online, very simple, but probably more detailed. This is, I think, as you can see, more than 80 slide definition, but you can just jump to what's relevant, the cosine of distance between two vectors. So you can take the embeddings of the vectors and determine the cosine distance and what it means. While I was familiar with the Jacquard index or the Jacquard similarity in terms of images, I was not familiar with how it's used in words or sentences. Again, found a quick Medium article on all the different ways that you can compute similarity between texts, and in our case, we can think of just the two questions as text, right? So this is just all the different similarity, and apparently I haven't gone through all of it myself, but even provides code for all these different things at the bottom of the article, I believe. So you can kind of go through these bag of words, cosine similarity, what is latent semantic indexing, blah, blah, blah. Again, the challenge in this case is, okay, these are all the various similarities. Now, how do I actually apply it to the corpus that we have in front of us? And then how do you use it to determine, at the end of the day, the probability that we end up with? So there's also an article here that I found about Jacquard similarity and shingling. Shingling is something that I'm not familiar with. So again, spend a little bit of time trying to come up to speed on what that is. So the point being that, at the beginning of the competition, at least my personal inclination, and I'd like Gautam and others to chime in and see what this team I know has much experience of things they may have tried and or are thinking about. But at least I tend to go broad in the beginning and try to familiarize myself with, okay, what's the task at hand? What kind of approaches have people used? What seems to be the pros and cons of the various different approaches, and try a couple of them that work or may not work before I focus on improving the score or, getting a good score or things like that. And I would encourage you to kind of start simple, make some submission, even if it's copies of existing notebooks, and then vary the parameters, see how things behave, and so on and so forth. With that, I think I would like for others to chime in and share what they have done and or the approaches they are taking. Gautam, for example, you had mentioned you made a submission, even if it didn't work. It'd be great to hear what kind of approach you were thinking of taking and what you tried.
Okay. So I just wanted to have like a simple baseline model. So what I did was shall I share my screen?
Yes. Go ahead.
You can see the screen, right?
Yes.
Okay. So yeah, I mean, this notebook is barely anything actually. So I loaded so first I kept my data inside Google Drive, and then so this is what the data frame looks like. And yeah, so the data is kind of imbalanced. So what my basic approach here was to just take an embedding for question 1, question 2, some pre-trained embedding, and just uh, calculate the cosine similarity between those two. And my initial approach was that I could choose a threshold for the cosine similarity. If it crosses some threshold, then it's duplicate, else it's not duplicate. So that I wanted to take just a simple approach. So So word embeddings like glove and word to vec are word based. So you would have to then do an average or something like that. And when you take an average, the ordering of the words gets messed up. I mean, it becomes insignificant. So what I did was I took the universal sentence encoder. So since it's a really good sentence encoding and which captures the meaning of the sentence as well. So I downloaded the USC model and kept it in my drive as well. It's directly downloadable from TensorFlow Hub, I think.
Mm. So is
So
the universal sentence encoding pre-trained model on some specific corpus of sentences?
yes, yes, it's yeah. So it's just a model
Right.
that you can feed a sentence to it, and it would just uh, give you a 512 dimension embedding back.
Vector.
Yep, 512 embedding vector.
Okay. Okay.
Yep, and it's yeah, it represents the meaning of that whole sentence. It's not a
Mm.
word based embedding like glove or anything like that. Um, then I wrote a function. So now I would have uh, vectors for each question 1 and question 2, and I want to take a row wise dot product, row wise cosine similarity of the questions, right?
Mm.
So I wrote a
Right. Right.
function
Yeah.
where I'll do just that. So this one is the dot product where where I multiply the embeddings and I take a sum. That's dot product divided by uh, the magnitude of the vectors of M1 and 2.
Yeah.
So this whole thing is the cosine similarity. So now I can feed in two matrices and I'll get uh, one column of the cosine similarities. So that was the purpose of this function. And then I iterated through the data set 100,000 at a time. Since it was too huge for the RAM was getting filled up. So I batched through it and I took the embeddings of question 1 batch wise. So this is the function that gives me the embeddings. The use embed thing is the uh, universal sentence encoder function. So I take my question 1 embeddings, question 2 embeddings, and I store all the cosine similarities in a list by taking the row wise cosine similarity, this function which I wrote here. And now this is what it looks like. I added that extra column. So when the sentence is similar, like what is the step to step by step guide to invest? What is the step by step? It's quite similar. The similarity is 0.93 and so on.
Mm.
So I just wanted to see what is the mean cosine similarity. So if it is not a duplicate, it's 0.65. If it's a duplicate, the mean cosine similarity is 0.71. Not too significant, but there is a difference. Um, and I just plotted it as well. I wanted to plot an overlay plot like on top of each other, but I was not able to do that. I left it.
Mhm.
I think there is
Yeah, I
some
was
difference.
wondering how you would threshold it. So it's kind of interesting that you determined it for both similar and non-similar, right?
Hmm.
Or
Yeah.
duplicate and non-duplicate. Yes.
Yes. Yes. Yeah. This is the mean cosine similarity,
Right.
and yeah, and the like the weird stupid thing here is that it's imbalanced. So uh, not duplicate is like 63%. So I wasted some time by setting
You think
thresholds and
that's
everything from
awesome? Do you think that that's significant enough to worry about? That's not too bad, right? It's
uh, I guess you would have to do some statistical test to see if it's significant. I'm not sure.
Yeah, I was also thinking along what the lines of what John said, meaning typically, I mean, again, in deep learning, this is just, you're just doing stats at this point, but if you had, in deep learning, it would probably not, it's like, what were you saying about 2 to 1? Is that what you were showing, Gautam?
The examples?
No, about 2 to 1, right? So 2 to 1 isn't terrible, but more for deep learning. But for simple statistical things, yeah, it may still, like you said, may require some statistical analysis to see does it matter or not. Yeah.
Yeah. Yeah. So here I wasted some time. So what I was doing was I wanted to find the best threshold, but I should have found out the F1 score or something, because since it's highly imbalanced, the best threshold was basically 1 and the accuracy was 63, because it's basically, it's imbalanced. So I could have done F1 score here or something like that. But then I realized what they wanted is actually probability output, right? So I don't have to even have issue. I can just output that cosine similarity. I mean, I can just rename this cosine similarity as is duplicate probability.
Output.
Yeah.
Yeah.
It's just the output.
Yeah.
So that's what I tried
Yeah.
to submit, and I came up with some error. So yeah, I read the test file. It has the question 1, question 2. Then I did the same things, and now I have a cosine similarity. So I just renamed that as is duplicate, and then I try to submit and some duplicate ID error. I think I have to check that out. Yeah.
Oh.
Yep. That was all I had. Yep.
Yeah, that's a excellent, good, simple approach, but may prove to be very effective.
And it's really nice to have a baseline, like this is like a logical baseline that you can use to then compare your smarter stuff with.
Yeah, and I think the other thing to point out is, I think, what the other thing to play with, Gautam, it may be worthwhile if you can share the notebook also, is trying, like, what are they called, the N-word combos of words, and then compare it to the, I forget what you were saying was the sentence
universal sentence
embedding, and see how much worse you are by just doing bag of words. You know what I'm saying?
Yeah. Yep. A TF-IDF
like how much more is your, sorry?
A TF-IDF based approach, right?
Something like that, yeah. Exactly.
Yeah.
And see how much worse. I mean, I would imagine that, I forget what were you referring to, the universal sentence encoding, right? Is that correct?
Yep. Yes.
Yeah. So, if you just did TF-IDF on the words of those questions and did a comparison, that would be interesting to find how much more the universal sentence encoding is able to do better, because it encodes the whole sentence and is aware of the position of the words, compared to just the N-word combos.
Yep.
But that's very fascinating. Yeah, I think it'd be very interesting to see whether how good your score is, even compared to some of the things people have submitted. Is the universal sentence encoder fairly recent, or is it been around for a while, or do you know?
I think a couple of years old, but they are actually constantly updating it. So there is a version 4 now that released like few months ago, I think.
Because if it's only a couple of years old, then it may even be that your score might beat many of the existing scores. I haven't looked at what all they have done, but barring more complicated stuff, if this uses recent techniques, I'd be very interested in knowing
what your score is when you submit. That's really good work. I think excellent reference point, and as John said, very simple but elegant attempt at solving the problem. Thanks for sharing. That's really good. Yeah, I think the other thing, and I didn't quite want to go there now, but you know, apparently the task that we are trying to solve is called something like paraphrase identification or paraphrase similarity. That is, you know, can you paraphrase sentences and see whether they are identical or not, or duplicate or not? And there's some state-of-the-art techniques for that. But those are things we'll get to towards the end of the competition once we've all tried different things, seen how they work. So, Gautam, do you know on this USE thing, do they use underlying word vectors, or?
It's some transformer architecture, but that's really all I know about it.
It's bird based.
It is bird based. Oh, okay. Yeah, because that was the other thing I was planning on trying is, you know, BERT is just word encodings, and the significant thing that I think Gautam has pointed out, which I think is important to realize in this competition, is it's not just the words, it's the meaning of the words that you're after in a sentence. So you need to kind of comprehend that or account for that. You can't, I think, just take the word embeddings and try to compute similarity. You could do that, not that you can't do that, but you will not end up with great score. I think the significance is in his use of the universal sentence encoding, which generates a vector for the sentence as a whole rather than just for the words. But
I think the universal sentence encoding is actually different from BERT. I don't think it's BERT based.
Oh, okay. That will be interesting. Yeah, if you see any, or you know, if you can post a link to that reference when we're done, that would be useful to poke into. But before you pointed that out, I was thinking one of the approaches could be simply taking encoder decoder kind of approach, or even our basic transformer that we've been spending time looking at 224N. And I was thinking maybe of feeding in the first question to the encoder and the second question to the decoder, and because ultimately translation is just, I mean, a variant, and seeing, and then of course at the top of the decoder you'd have to have some classification type thing of 0 or 1. But I was thinking of that as being worthy of an attempt too. That is, you provide the first question as the first thing that you're trying to translate to the encoder, and then provide the second question to the decoder and see what output you get in the decoder and slap a classifier on top or something. But your approach is even simpler because the sentence encoder solves that problem. Great. Any other suggestions or thoughts from people? Anybody else attempt anything?
I have something very similar, actually. Yeah.
You want to share, Yuri?
Yeah.
Yes, we can see
Am
it
I
now.
showing? Okay.
Yes. Yes.
Actually, on like just to finish your thought, so I also use like basically a pre-existing sentence encoding, but I kind of like this idea of training because then you actually use you know, labeled data, because in this approach you just use pre-trained, you know. If you use sentence encoding, you just it's an unsupervised problem. But if you actually want to train you know, BERT-like model with like first and second sentence, then you're actually using labeled data. So anyway, so I did actually I submitted like a stupid thing. I just to see if submission works. I did like a random, and random gave me a Jan score of 17, and then I looked at what's the percentages in the test in the train data, and did the same mix of yes and no answers, which was like 40%, and that gave me a better score. That gave me like 17. But I'm trying to use I don't know if it would be a baseline or not, but I just want to see like this is readily available, and I used this sentence transformer before. It's less than a year old. Like this is a reference. It's
So it just generates. It's like it's similar to the sentence thing, but use that universal sentence encoder that Gautam was referring to, but using transformers.
Yeah, and it's very recent. So they actually there's an interesting there's an interesting conference. It's called Empirical Method in NLP, and they actually have like several sentence embedding presented there. So actually I want to look at them all because that's what kind of closer to what I do, and I really wasn't using sentence embeddings till now, but this is extremely easy to use.
Yeah, so at like least to me, the whole concept of sentence embedding is somewhat new that this problem is exposed to, because until now, at least I hadn't heard of, I'd heard of TF-IDF, but I didn't know that there was such a common sentence embedding paradigm.
Yeah, and I basically, like, main thing why I switched to them in my work is that I tried using BERT embedding on sentences and just doing like a mean value of embeddings for each word, which supposed to work somewhat, but it wasn't picking up negations. But those sentence embeddings pick up negations really well. So like basically, negative word in the sentence would push it away from similarity. So I did not submit this. I was just actually playing with it, and I calculated the. So I'm not sure if I'm printing the answer. I calculated it was getting it right like 70% of the time.
Yeah, from my poking around, in fact, the benchmark seems to be around 87, 89.5. Not just for this competition, but in general for the task. So, your 73 or whatever is pretty good.
Yeah.
Cool. That's a good idea too. I didn't know. If you could post a link to all this various sentence embedding references, that'd be great. That'd be interesting to look into. Awesome. Thanks. Steve, you were sharing some Eda notebooks. Would you want to just highlight that share?
Yeah, basically, I haven't had a chance to like submit anything to the competition, and I haven't looked into it very much. But pretty much all Kaggle competitions within the first couple of weeks of them starting, people publish these EDA notebooks, which just analyze data and sort of run through all the data to show sort of what's contained in the data. So like they're always worth looking at to start with. So it's not as if it's sort of it doesn't sort of give away the problem or whatever. It just lets you sort of have a look at.
Yeah. Yeah, we'd be interested in seeing what.
Sorry, can you see that?
Yes. Yes, we can.
Yeah, so this is just if within the competition itself. I lost the competition now, but
oh yeah.
Oh yeah.
Wow.
Yeah.
You're
So
doing a lot.
This is just one of the top notebooks in the thing. So like basically, yeah, it's just got like a good explanation of the problem and what exactly you're trying to achieve, and then it like as Gotham had, it's like just shows you the questions and looks at the training set, and like then it's just got like a lot of graphs analyzing what's in the training set and what's in the test set. And yeah, so according to this, it says that the test set's like way bigger than the training set, and it looks as if the test set may contain like a lot of sort of false values, really, like ones that have been auto-generated that aren't real questions, just to make things a bit trickier and check stuff out. But yeah, for anybody sort of starting, it'd be worth them looking at this notebook. So it just gives you like a good idea of what you need to do. The solution here.
Yeah, also,
I think he does. Yeah, he's got like
even the way to analyze the NLP data set, right? Like how all and the graphs that he has plotted of the words and stuff would be interesting tools to have in the toolbox of how to analyze NLP data sets even, right?
Exactly, yeah. So he's using something similar which does some sentence thing, but then he's sticking it through whatever it is at the top there, XGBoost, which yeah, so 4 years ago, whatever, it was probably quite good. But yeah, so there's a couple of like EDA notebooks. I've only taken a look at this one, but I thought he explained the stuff very well as to what the problem is.
Cool. Yeah, I think this is a good one to spend some time and also kind of, at least to me, learn the techniques that he's using to analyze so that they can be used in other NLP competitions and stuff, plotting the graphs and overlaying, test and train, and things like that. Cool. Anyone else that wants to share approaches, thoughts on what the problem is, early ideas, or for that matter, don't be shy about sharing challenges or issues you've had trying to deal with the problem or deal with Kaggle. No? Anyone?
I just want to check if anyone got a score, like was able to make a submission and do a score.
Yes, Mehul, I was.
Okay, cool. Thanks.
And it ran pretty quickly. Now the one thing is I used a fairly recent notebook of about a year back. It was gradient boost based, and it generated multiple submissions, and I tried at least with 2 different submission CSVs, and it scored fairly quickly, a lot quicker than some of the other ones that I'm used to. So it seems to work. The data seems still to be active, meaning no issues with the data. No issues with scoring. That happens fairly quickly as well. So I think in that sense, the logistics are all set. So I think I would And it seems like it's a fascinating competition because, as people have already pointed out, Yuri, Gautam, and stuff like, you can use modern techniques, and it's not a simple, let's just take the words and standard translate. For whatever reason, this paraphrasing thing seems to have been very active several years back, but then died away a little bit more recently. So from that perspective also, it's interesting to see, and the score is not in the, it's as good as humans. It's more in the 89 point something as the best case. So a lot of good reasons to try to do variety of things. And I think Gautam and Yuri have both demonstrated some fairly simple approaches, which with modern techniques, which can be very useful to try and then, improve upon or try something different.
Sounds good. Thanks.
I think the interesting thing about this competition is that you'll have to have two inputs to the model. Like most of the time we are used to seeing a single sentence and you're classifying it as this or that. So here we would have to input two things at a time. So I came across this like special architecture called Siamese models. I don't know if
Yeah, I was
anyone has
about to say that,
experienced.
Gautam, that the Siamese thing, which I know that Rekhil and Mehul and so on are very familiar with, maybe even Steve, on the imaging side, Siamese is quite common. Go ahead. Expand on what you're going to say.
I just wanted to ask if anyone has any experience with those Siamese architectures. That was my question.
We worked a little with
Rekhil, Mehul.
we've worked a little on the imaging side, but it'll be very interesting to see on this side. NLP, how do you use Siamese? Yeah, I agree. That's quite interesting.
So was it for a similar thing, image similarity or something?
Yeah.
Basically use it like for face recognition, right? you basically will have you have Gautam's face and you don't want to train it with every other non-Gautam face. So you basically build it up in such a scenario where you have Gautam, and then a few other changes. The losses, I think, are different, if I'm not wrong. You use a kind of different loss there, but this is all image related. You need to see how it kind of translates to NLP. And FastAI
there's even FastAI notebooks. Sorry, go ahead, Ricky.
No, that's what I was just saying. FastAI has a notebook which has a Siamese. I don't know how much is built up after that. Jeremy was using it for showing how to build your data loaders. I don't know if someone else completed the notebook.
I think the other guy who, I forget his name now, but
Silvan completed that.
Mueller. The Mueller guy had a notebook, again, illustrating basically loading, but not doing too much other than similarity. I have to go back and check, but I'll post the link if I can find to his notebook. Again, it just loads it and sees whether but it essentially checks what we are trying to check here is, and to Rekhil's example, is this similar? Are the two images identical or not? Which is kind of the same thing we're trying to do here, is duplicate.
Right, yeah.
And I also found a Medium post that talks about it in an NLP context. I'll post the link to that.
Yeah, in terms of image, again, I think Andrew's Coursera course has like a couple of lectures on that, where he again explains why you need it, what's the loss, and that kind of stuff. But again, that's all image related.
Sorry, which course you're referring to, Rick?
Andrew's, I think the Coursera, the deep learning one that he has, one of the image sections kind of deals with that.
Yes. Although you're right. I think there is a section where he goes into this, and he uses exactly the example you refer to, right? Like how do you determine for security check of access or something?
Right,
yeah. Excellent. So I think that, Gautam, is a good cross-link to what happens in what's common in imaging, or at least has been explored in imaging, but it'll be interesting to see how it's brought into the NLP world from both the loss and from the adjustment to the the sequential nature of words and things like that. So that's a fascinating thing to explore for sure. Any other inputs or comments or things people want to share, ask questions which can be answered interactively? No? Okay. I would encourage everybody to try to post. I think formally we'll stick with this competition. It's definitely a fascinating one. Hopefully will teach us a lot about variety of things that we could be trying. Thanks Gautam, Yuri, and Steve and others who have shared their approaches. I'll post a link, and Gautam, Yuri, if you can share whatever links you feel are appropriate and pointers to your notebook that you feel are worthy of sharing, that'd be great. And hopefully all of you, I'd encourage every one of you to try and make a submission, at least an attempt at it. And if you encounter any problems with Kaggle or with, approaches to getting it done on Google Drive and stuff, feel free to post your questions on Slack, and hopefully you'll get responses from people who have tackled it in the past. Okay. Thanks everybody for joining, and hopefully next week we'll have more ideas and more people having submitted and results to compare.
Thanks, Srinivas.
Any last comments? Joseph, did you want to say something?
No, I just wanted to say thank you for this session. It was a good introduction.
Sure.
I still haven't played with notebooks, but I hope to this week.
Yep, it's like the Nike slogan. At some point you just do it.
Yep.
But it's always hard to get over that hump. Once you get into it, it's addictive. So, you always want to try something different and full of ideas. So I think the thing I'd most encourage people to do is get their first submission in and get the first notebook working and get the first thing done. And then you'll find that you want to do more because you just want to keep trying to get better or trying to learn some new things to try. Okay, thanks everybody for joining.